Hello and welcome to Information Technology Video Developer Network. My name is Abdurrashid Hamid. I'm a certified Microsoft specialist working for Cyber Bionic Systematics. The topic of our lesson today is loops. We're going to discuss how loops are used in different applications. So let's start our lesson and I hope it will be interesting for you. Okay, let's start by looking at the definition of a loop before we go further. Now, a loop is a control structure designed to organize a multiple execution of a set of instructions. So it basically organizes a multiple execution of a set of instructions. What does this whole sentence mean? Here you have something here. Just look at this bottom where my mouse is. You have while. Now everybody knows while. It's just like if here, but here we have while. So while this condition, we have a condition here. We have the while operator here, we have the condition here. So if this condition or while this condition is true, we'll perform these series of instructions. This is like the body of this conditional statement. This is the while conditional statement, and it consists of two parts, the while part and the conditional part. So this condition is the second part, and if this condition is true, we'll go into this body and perform a series of instructions here. If this condition is not true, we don't perform anything here, we just go out of the loop. So imagine that the condition is true. We perform one iteration and then we go out. So I said we perform one iteration. What is one iteration? An iteration is a single pass of the loop. Maybe I should say just a single circle, one circle. So it goes one time and goes out. That's one iteration. If it goes 3 times, it passes 1, 2, and 3. So we have 3 iterations. Now, let's move on to the next slide and look at goto. Goto is an operator of an unconditional jump. Let's look at the meaning of goto. Goto is an operator of an unconditional jump to a specific point in the program, specified by line number or label. So line number can be, you know that we have in our Visual Studio line 1, 2, 3, 4, 5, just somewhere here on the left hand side, or it can be a label. A label is just something you create, a name. It can be anything. This can be, let's say, it can be start, and it can be anything you want. So let's just leave it as label here, okay? I'll rename it start there if it's not start. So you can name it whatever you want here. Label of jump. So what this does is if you write go to label, this go to will jump up and come to label and then perform this body again. It will write, in this case, hello. So here we have console write line hello. It's going to write hello, then it will go and go back to label, write hello, go back to label, write hello, go back to label, write hello, and it will continue indefinitely because we don't have a break, we don't have an end here. It will just be like an infinite number of circles or iterations. So if you're wondering if this will ever end, no, it will not end. It will just continue writing hello, 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 and I will show you in our example as we start. Let's even go to the example straight and I will show you what I mean. Here we have the same thing there. I renamed label for start. So we have start, console write line hello, and go to start, and we go back here. If you want, you can take it back and you put it back label, it will still work. Go to label. Let's just try it and see. So let's run this program. You see it's writing hello, 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 hello. It will never stop. It will never end. Now by changing start, let me take it back to start, and running this program, it won't change anything. Let's run the program again. The same thing. Hello, 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 hello. Let's close it. So either start, hello, whatever you write, as long as these two words match, you're okay. It's the same. And maybe you will decide to write something like, put it somewhere down here. It will still work. There is no problem. Just, it doesn't have to be on the same line. It can go to start and then enter the body or the block of start. Let's run it and see. You can see it here. So let's put that back and Control S to save. Now you see what I'm talking about. Okay, so let's go to example 2 straight and look at this. Here I left it at label. Now here we have a counter. Operator of an unconditional jump goto. I want to show you the use of goto, but here we have a counter. Remember, a counter is just something that counts the number of iterations we have, or it can count, let's say, the number of times we have here. Now, we have an if conditional here. In line 11, we created an int-typed variable, named it counter, and assigned a value of 0 to it. So here, basically, counter is 0. Here, you remember this sign, the increment sign. It's post increment. If these two plus signs were before the counter, then it's pre-increment. But here we have post increment. Okay, so this post increment is just adding 1. It's like counter plus 1. So here we have 0 plus 1, then we'll write counter 1. So here the console will write counter is equal to, and it will take the value of whatever our counter is and put it right in here. In this case, it's 0, so it's 0. It doesn't matter. And in line 17, we created an if conditional statement. This is our keyword if for this statement, and then the body or the conditional part. So the conditional part has a counter, which is this counter, and a sign. This is the less than sign. And then we have some kind of value. We want it to be like a control for us. So now you can see after all this, we applied goto label. So what we're asking it to do is, if this number is less than this number, go to label. So it will go back here and it will go into the body, increase it by 1, check it again. If our number is still less than 3, then it will go to label. But if our number is more than 3 or equal to 3, then it will not go into this body. It will just go to line 22 straight and write end on the screen. Let's step this program and see. Remember stepping your program, F11. So here we have it. Right now you can see we don't have anything written. So value of counter is equal to 0. Then remember this increment sign. It's still 0, but once we go out of this, it will change to 1. So now we have increased 1 to our counter. Let's keep on stepping, F11. So you can see the value of our counter here is 1. It will take this 1 and print it right into our screen. It will put it right in here. So now if we are to check our console, we'll see counter is equal to 1. Okay? All right. Let's close that. Oh my God. Okay, let's go back. So here we have counter is equal to 1. We're back to normal. And let's keep on stepping. If counter, which is equal to 1 now, is less than 3. Is this true? Yes, 1 is less than 3. You can see here you have a kind of tip here. So counter is less than 3. What do? We go into the block of this if conditional. So let's go into the block and go to label. So what do you expect now? It won't go to line 22. It's going straight to label. But it won't come to this line. It will come straight into the body. Okay? So it will come back and increase it by 1. So let's go. Here we have counter still 1. So we're going to add 1 to counter now. When we step out, you'll see counter is equal to 2. And here counter is 2. So what we're expecting is it will write 2 on our console. Here we go, 2. Let's go back to our stepping. Now counter is less than 3. Is it true? Yes, of course. 2 is less than 3. You can see true here. So what do? We go to the block. We enter the if block and go to label. So we go back and add 1 to our existing 2. Here we have 2, add 1, it becomes 3. So now we should have, once we go out of here, we should have 3 written. Counter is equal to 3. Okay. What's next? Now counter is 3 and our control number is 3. So is this true? No, it's false. Are we going into the label? Are we going into the if block? No, we are not going into the if block. What we are going to do is we'll just go and write end. It's just going to go and write end now. So we're going to jump it here now. You see? So here we're going to write end, and once we go out of this end, we'll have end just here. So let's stop this program. This is how you can use goto in conditional statements and in other statements. This is just like an example, an easy example to show you that goto can jump to a specified place, and you can specify this place. Okay? All right. Let's go into the next example of goto and see. Here we have a Boolean construction. In line 11, we created a Boolean typed conditional variable, named condition, and assign a value of false to it. And in line 13, we have our conditional operation here. Remember the if word and our conditional operator or body. So here the condition is condition which is false is equal to true. So is false equal to true? No, it's not true. So if it's like that, we go into our label. But condition, we know that it's not equal to true. So we're not going into label, we're just going to line 18, and you'll see first line printed and second line also printed. Now, let's see. Step in the program. Yes, our condition is equal to false. If condition is equal to true, is our condition equal to true? No. So, first line, we're not going directly to label, we just go in here first and then here. And here and step out, you can see it's written here. First line, second line. Let's do that again. F11. So our condition false, we are checking it here. False is not equal to true. That is a false statement. There are two different things. So if it were true, we'll go to label directly and we will not print out this. This will be excluded. But this statement is not true. Since it's not true, what we are going to do is we'll print out the 18th line. So first we go in here, we go out, and you can see first line has been printed, and jump out of here, and the second line has been printed. And that's it. So that is how to use label also. What if we change this to true? Let's change this to true. Okay, we've assigned a new value to our variable, which is called condition. So now true, true. Condition is true, which is equal to true. Let's step it and see. What we should expect now is, since it's true, we're going directly to our label. F11, F11. Is it true? Yes, it's true. So go to label, and there you have your jump. So now when we go out, the second line will be printed out, second line, but the first line will not be printed out. So that is how to use label and jump from one place to another in your code. Control Z, put it back to how it was, and that's it. All right, let's go back to our presentation and continue. Now we have finished with goto in this operation, or in this slide. We have seen that this slide just keeps on writing hello, 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 hello if we have it in the code. So there's no end to it, and it will not stop. It will keep on writing until maybe your battery runs down, or you shut down your computer, or you close the application. So let's go on to the next slide, and I will show you something that we have already done, but I want to just repeat it here in the slide. Loop with a precondition. You have seen this already, but I want to explain the meaning of this precondition, so I brought you back into the slides and I will show you. Loop with a precondition while is a loop that executes an instruction as long as the condition is matched, or as long as the condition is true. Don't worry, you already know this now. You're just going to listen to me and you'll understand it. You have already understood it in our examples. So here we have our int-typed variable named counter and assign a value of 0, and while counter is less than 3, add 1 and keep on going. You have already seen this. It's nothing new to you. So what is going to happen? Counter is 0, you add 1, counter becomes 1, 1 is printed, this 1 is taken and put in here, and then we go back and we check. 1 is less than 3, 1 is added again, 2, go back and check, 2 is less than 3, we add 1, 3, so go back and check, 3 is not less than 3, is equal to 3. So if it's not less than 3, we go out, we don't add anyone. You have already seen this in our example. Now, what does a precondition mean? A precondition simply means you have the condition first, and then you have the body. Okay, so this is a precondition. A post condition is you have it out here. This while counter is less than 3, you have it after the body or after the increment. This is just like a diagram to show you again and make sure that you understand. Here we have our condition. If our condition is true, we go into the set of instructions and go back. Check again. If our condition is still true, we keep on repeating. So we have a lot of iterations, but if our condition is false, we just go out. Simple. So on this slide, what I just want you to remember is you have a counter, you have a condition, you have your while, it checks if the condition is true and it goes into the body. If the condition is false, it goes out of the body. And because we have our check before the increment, it's called a precondition. So let's go to the next slide and look at post condition. Here we have it, do while. A loop with a condition do while is a loop where the condition is checked after the loop body has been performed. The body of do while is executed at least once. You must somehow run the instructions no matter what. So let's look at it. Contrary to our precondition, our post condition here, we first increase the value of our counter by 1 and then we check. Remember here, we first check and then increase. This is in the precondition. In the post condition, we first increase, print it out, and then check. And if our condition is true, we go back and do this again. If our condition is not true, we go out. So do this, which is an increment. In the body of do, we have an increment here, we write it, and then we check. This is how it looks like in the diagram. You have set of instructions first, that's this, and then we check our condition, which is this. If the condition is true, we repeat the instructions. If the condition is false, we go out. Simple. Now, we have also seen that in our example. Let's move on to the next slide and look at loop counter very fast. And the last type of loop we have is the for loop. Now, we have 3 types. The first one is while, second, do while, and the third one, for. So, let's look at for. Loop counter for is a loop where the variable, the counter of iterations, changes its value till the target value is reached. What does this mean? Let's look at it carefully. We have our for here, which is 4. See, we're putting it here. And in this open and close parenthesis, what we have here is an int-typed variable named counter, and we have the assignment sign here, and we assigned a value of 0 to it. And then after this creation of our counter, we have our conditional part here. If this counter that we just created is less than 3, then perform this instruction. So we keep on increasing. This is the increment sign. Remember, we have counter plus 1. So we keep on adding 1 to our counter until we reach our target value, which is 3. And then we keep on displaying the counter. Counter 1, 1, 2, 2, 3, 3. That's all. Then we move out. End. So what do we have here? In the diagram here, we'll understand it maybe a little bit better, but I think you understand it here. But let's just look at it. Creation of counter. This is our creation of counter. We just created a counter, an int-typed counter or int-typed variable, and assigned a value of 0 to it. So this stage has been passed. Let's move on to the next stage, our condition. This is our condition. Counter has to be less than 3 before this instruction is carried out. So our condition is here. Then if our condition is true, we go into set of instructions. If our condition is false, we go out of the loop. So if the condition is true, set of instructions 1, which is counter plus 1. So our set of instructions here is just a simple instruction, an increment instruction. We just add 1 to our counter, and then change of counter. What we mean here by change of counter is the value of counter changes, and then it is again somehow checked here by our condition, and we go out. Notice that we don't create another counter. We just go back into our line and check our condition again. If it's true, we move into set of instructions. If it's false, we go out. I'll show you all this right now when we move into our examples. So let's go to our examples, and I'll show you all this do, while, for, and so on and so forth. Here we have while. This is our example number 4 for while. You already know what's gonna happen here. I'm very sure of that, but just in case, let's just step this program. Here we've created our counter. In line 11, an int-typed variable was created, named counter, and assigned a value of 0. In line 13, we have our while condition here. So we have while, the keyword, and the conditional part. And our condition, this counter, which is 0, has to be less than 3 for our block to be performed. So the while block will only be performed if this is true. If it's not true, we go out and we move to line 19, and we'll put the value that we have here, maybe 2 or 3 or 5, I don't know, and then we put it in here and say, for example, 3 iterations were performed. Simple. So let's step this program and see. Creation of a counter. Counter right now is equal to 0. Is it less than 3? Yes, it's true. So what do? Move into the body. Counter is 0. Counter plus 1. Counter is now 1. And console right line, we put the value of our counter in here, and you'll have counter 1. Let's keep on moving, and we go into our condition again, and we check. While counter is less than 3. Counter is less than 3. It's true. 1 is less than 3. What do? Do we go out? No. We add 1. So we add 1. 1 plus 1, 2. So now our counter should have a value of 2, and we put it right in here. It should print 2 as soon as we move out of this. Counter 2. So next, what do? We go in and check again. Condition 2 is less than 3. Is it true? Yes, it's true. So we move into the body. Counter now is 3, because counter plus 1 is 3. So here we should have 3. Once we move out, it should print 3. counter 3, and we go in and check again. While counter is less than 3, 3 is less than 3. No, it's false. So we're not going to add anything, and we'll just move out here and count the number of iterations that we have. So now it should print 3 iterations were performed. Let's see. 3 iterations were performed. So you can see it's very simple with while. We have seen the example in our presentation, and we've seen how it practically works here. Let's move on to the next example and see. Here we have basically almost the same thing. While with a jump, but this time please take note, we have a break here. A break simply means that we're going to end the instruction no matter what. If it's true, if it's false, we don't care, just break it and end the operation. So let's look at this. We have almost the same thing here, except for this break. Counter again was created, an int-typed variable named counter, and assign a value of 0. And in line 13, we have our while construction here, while, and on the body, counter less than 3. You remember this. Counter plus 1, you also remember this. But look at this. Here we have a new thing, break. And I told you that break is just that will just break this operation. Even if it's less than 3, we break and we go out. But let's see what's going to happen. Let's step this program together and see. So counter is 0, counter 0 less than 3. It's true. Counter plus 1, so now counter should be 1. Here we have 1. Okay, now it's the time where you will see this. Break, what do you expect? You want it to go back? No, it's going out. Although counter is still less than 3 and it's true, but because of this break, we'll just jump out and move out. It will not execute this line at all. Console write line, it will not execute it. It will just go out of the loop, out of the body, because here we have, you can see here, this is one block. Okay, so because of this break, this whatever you have here will never be executed. It will never be performed. It will just go out of this body. Remember, this is one block. Yeah, open and close curly braces means one block. So if you have break in the same block and you have a lot of things, whatever you have below the break will not work. It will just go out. So you see here we have counter 1. Now what do you think will happen? Console write line, 1 iteration was performed. Let's read the key. 1 iteration was performed. So you have seen the use of while, but in this case we have a break. So a break means even if our condition is true, we still go out of our block. Let's look at another example with while. While with jump statement continue. So there we looked at break, but now let's look at what continue will do. Okay, basically we have the same construction here. We have the same thing, an int-typed variable named counter, assign a value of 0, while counter is less than 3, perform this increment operation. Okay, but then we have continue. So what continue will do is just like another goto. Okay, it will just continue doing it until we have the same thing. But let's run the program and see what will happen together. All right, so counter is equal to 0, counter plus 1, counter is now 1, counter 1, and we should somehow have 1 here. Yes, because we asked the console to take the value of this counter and put it right in here. So we have counter 1. Let's minimize this. Continue. So what will happen? Go back and check again. So continue is just like a hidden goto. It's just like a hidden. It has the same like operation, or it has the same function in this case. Okay, in this case it has the same function as continue. So it will keep on doing this until we meet or we achieve our targeted value. So let's keep on doing and see. Now counter is 1 less than 3, true. Counter should be 2 now. console write line. Now we should have 2, counter 2, correct? And what will happen next? Since it's true, we go back. Counter 2, let's add 1, write 1. Now our counter is 3 and the value of our maximum value is 3. So let's see what will happen. It goes back and checks. Counter is 3 and our maximum value is 3. Counter is less than 3, false. So we're not going to perform this and we're just going out of what we have. Now also notice that we're just going out of this. We don't execute this line. It's just like a break, but a break stops this operation. Continue doesn't stop this operation. Continue lets this operation finish first, and once the operation is finished, it goes out of the block. But break stops everything and goes out of the block. So again, line 20 will not be executed. So we'll have 3 iterations were performed. Let's check it. Sorry, F11. We have to F11, read key. Now we have it. 3 iterations were performed. And that's it. Let's close this. So remember, the difference between continue and break at this level is that continue stops the operation and goes out of the block immediately. Anything below break will not be executed. But continue allows the operation to be finished first and then goes out of the block. But again, anything below continue will not be executed. So we have done that. Let's play a game now. So now let's create a very simple game. Very simple but yet very interesting game. We are going to use the while loop for this game. Now, of course, when you're starting a game or when you're creating a game, you have to print out something like an instruction to the user, okay? So in line 11, we print out this, and what we have here is guess the hidden color. You have a maximum of 5 attempts. And then we have to tell him how to exit the game if he doesn't want to play it. To exit the program, type exit and enter, press enter. Let's say to exit the game, since it's a game. To exit the game, type exit and press enter, okay? So what will happen now? Look at line 14. In line 14, what we have basically is we have created our game right in here. From line 14 to line, let's see, to line 42. But first, let's test this and see if it works. Once we press start, we should see, guess the hidden color. You have a maximum of 5 attempts. To exit the game, type exit and press enter. Okay. That is working right now. So what do we do next? Let's create our game. In line 14, we create a constant typed integer variable and named it max attempt and assign a value of 5 to 8. Remember that this constant means we can't change the value of this 5. We have already allocated it. So the allowable number of attempts is 5, or let's say the maximum allowable number of attempts is 5. Control S to just save that. In line 15, we created an int type variable named attempt and assigned a value of 0 to 8. So the first attempt will have, this is just like a counter, okay? Remember counter in our previous example, you can name it anything you want. Here we have just named it attempt. So counter of attempts. First attempt, it will show you 0, 1, 2, sorry, first attempt, second attempt, third, fourth, and fifth. Then our hidden color is red. So here we created a string typed variable named color and assigned a value of red to it. So this is our hidden color, okay? Let's do it like that, hidden color. Then in line 18, we now created our while conditional statement. While attempt is less than maximum attempt. So while this value is less than this value, run this or move into the body. And in the body, what we have here is in line 20, we have an increment operation here. The increment operation is we take the value of the attempt that we have. Now it's 0, we increase it by 1, we have 1, and we somehow print it. Okay, attempt 1. And the person tries. Maybe he writes green or blue or yellow. If it's not red, what would happen is we'll check it here. String value, which is red, is equal to console read key. What we are saying here is console read key is we are going to assign the value of what the user inputs to our value, and we'll see if it works. Now this is maybe green or yellow or purple, something the user, some color that the user decides to write, and then we'll assign it to value. Okay, after assigning it to value, we'll move into our conditional part. If value is equal to exit, remember that this is the assignment sign and this is our equal to sign. You have double equal to signs, means equal to. So if the value, that means what the user types in, is equal to exit, then break. Remember break, it means stop doing whatever you're doing and go out. Move to the last line. Here is line 39, and it will write game over. But if it's not equal to exit, then we move into our next conditional block. Our next conditional block, we compare what the value that the user inputs and our color. Our color is red. So if this is green and this is red, it means continue. And we go back to the next attempt, we see how it works. If it is red, we just, congratulations, you have guessed with, and we take the value of attempts here, we put it here, and goodbye. Then again, we write game over. Let's tap the program first. Here we have guess the hidden color. You have 5 attempts. Okay, once we move out of that, we'll see to exit the game, type and exit and press enter. Then here we have maximum attempts. Here you have color red. This is our, this is our color, yeah? So our color is red, our hidden color. While attempt, here our attempt is 0. What is the maximum attempt? 5. Is attempt less than maximum attempt? Yes, it's true. So we increase 1. Now attempt is 1. Okay, so we print console right line attempt 1. Basically what we should see here is attempt 1. Then let's say the person types blue. I doubt this will work right here, but let's see. Okay, we can do it right now, but you get the idea. So if the person types blue, what we'll do is, it's not exit, so we go into our block. But if it is exit, look at what happens. If it is exit, attempt 1, exit, enter, game over. You see? So that's if it's exit. But if it's not exit, what it will do is it will keep on comparing the colors and red. So let's try blue, for example. Attempt 1, blue. That's not our number, sorry, color. Attempt 2, let's see, green. Now attempt 3, yellow. Attempt 4, let's just say it's red. Congratulations, you have guessed with 4 attempts. Game over. But if you reach the maximum, of course, it will just write game over and that's it. So that's how to create a very simple and easy game using while. So we have a while and conditionals and a combination of break and continue. If it is break, it means it's exit, so we just go out. If it's continue, it means you haven't guessed the color and you have to go back and try again, and try again. Very interesting game and very simple to create. So let's review once again and just look at do while with a break, without a break, and with continue. Basically, it's the same thing that we have done, and we're just going to make sure that we understand everything before we move on to factorial. Now, here in line 11, we've created an int-typed variable named counter and assigned a value of 0 to it. And we have our do block here. This is our do block. And we have our while and the construction of a conditional here. So we have a condition here. If counter or while counter is less than 3, we do this. This is our increment, if you remember, post increment. So counter plus 1. Now, what we're going to do is we'll step this program and see if we understand everything and how it works. F11. Right now, our counter is equal to 0 because we haven't increased it yet. So we move into the do block. Counter plus 1. So right now it's 0. Once we move out, it will change to 1. So now we have 1. And we're going to write the line. So we'll take this value of 1, put it right inside here, and have counter 1. The console will write that for us. Let's check that. Counter 1. Fine. Let's continue. Now, we now check our condition. If it's true, we repeat. If it's false, we go out. So, while counter, which is equal to 1 at the moment, is less than 3, we keep on doing this block. So, is it true? Yes, it's true. Counter is less than 3. Let me just show you that. Here we go again. So we jump into the do block again, and right now our counter is 1. We add 1. It's 2. We check again. Counter is 2, which is less than 3. It's true. So we jump again. Counter increment. Counter is 3 right now. So you have counter 2. Sorry, I forgot to show you that. And then we move in and check. Counter 3, maximum 3. Counter is less than 3. False. So we're not going to go into the do block. We're going to go out and print this out. So what we expect is we'll put counter, this value 3, we'll put it inside here. So we have 3 iterations were performed. Okay, let me just change this to were performed. So 3 iterations were performed. Now let's run this and see. 3 iterations were performed. So this is do while for you. Now let's move on to do while with a break. Remember that a break stops the operation and jumps out. Okay, so this line will never be executed. Now let's see how it will work in this case, because we have while out of the block. So let's step this program. Once again, our counter is 0. Do, the body of do, break. This will not be executed. Our while and conditional statement here, while and our condition, and then we want this to be printed out, this result. Okay, fine. So let's step the program. Counter is 0, you add 1, counter is 1, and counter is 1 here. So we'll see counter 1, counter 1. Keep on running, and you see we break the operation. We don't execute this, neither do we execute this. We'll just see 1 iterations were performed. 1 iteration is performed. So this is what we are expecting to see now. 1 iteration is performed. Let's jump out of here and see. Read key. one iteration is performed. Simple. So when you have a break, remember it jumps out. It doesn't execute neither this nor this. So it just jumps out and ends your program. All right. Let's take a look at the same example with continue. Now with continue, having the same counter and the same do block, just continue is the difference between this example and the previous example. There we had break, here we have continue. So what do you expect? We'll keep on running this program, running this block until we reach our desired, or we reach our targeted number, which is 3, and then we write this. Okay, so let's see how it will work. F11, counter right now is equal to 0 plus 1, counter is 1, counter is 1, continue. We check what's happening. Counter is 1, which is less than 3. Is it true? Yes, it's true. Go back into the body. Counter 1, add 1, counter 2, and now counter 2 is less than 3. True, true. We jump back. Increment. Counter 3, counter 3, continue. So we jump to our condition. We check it. Counter is 3, and 3 is less than 3. It's false. Our counter is not less than 3. Our counter is equal to 3. So what do? We jump out. And now we're outside. Counter is 3. When we run the program, what we should see is counter 1, counter 2, counter 3, and 3 iterations were performed. So let's F11 again, and here we go. Counter 1, counter 2, counter 3, 3 iterations were performed. So this is how we have do while with a break, and of course do while with continue. So now I guess you understand the difference between continue and break. Good. As we agreed, let's move into factorials. So don't be frightened by all this, and it's very easy, it's very simple. In short, we have done this in schools, and now we'll just repeat what we have done and put it into programming. So for the loop do while factorial, this is what we do. A factorial of number n, denoted n factorial, is the product of all its natural numbers. So this is the meaning of factorial, the product of all the numbers, meaning the factorial of, let's say, 3, for example, it's 1 times 2 times 3, and that's all. And the factorial of 4 is 1 times 2 times 3 times 4, and that's it. But we don't want to count that. We want the computer to count it for us. For example, this here, what you're seeing here in line 8, is just the factorial of 0 is equal to 1. This is a mathematical rule, and I cannot explain it, and I don't even want to do it. So here we go. Now here what we have is we have a situation. We have A, B, C, D. These are, let's say, for example, 4 different locations. And let's say you have to deliver something to these 4 different locations. Location A is, let's say, London. Location B, New York. Location 3, Berlin. And location 4, let's say it's Moscow. Fine. So we have 4 different locations. And we want to know how many variants we have. Maybe we should first go to Berlin, then New York, then Moscow, and then London. That's not a good idea. Maybe we should first go to Moscow, then Berlin, then London, then New York. Well, I don't know if that's the best idea, but I just want to know all the variants that I have. So the factorial of number 4 is 1 times 2 times 3 times 4. Well, here I just decided to write the answer so that you'll see we have 24. But how is this possible? How did we get this number? We'll just look at it in a moment. Here you see all the variants we have, all the 24 variants. You can first go to A, then B, then C, then D, or A, B, D, C, or A, C, B, D, and so on. So let's move on to the body and look at what we have done. Here in line 26, we've created an int-typed variable named counter and assigned a value of 4 to it. And in line 27, we created also an int-typed variable named factorial and assigned a value of 1 to it. And then we write console write line, factorial number of counter. What's our counter? 4. So factorial of number 4. Okay? So next we move on to our do while operators. Now in the do operator body, we have this construction. First, multiplication and then decrement. So we have factorial multiplied by counter. Then now we have a post decrement. Counter minus 1. So if our counter is 4, here we'll decrease 1 and our counter should be 3. And if we repeat the same circle, what we'll get is counter, which is 3 minus 1, we'll get 2, and then 1, and then 0, and then that's over. Then, let's say, for example, this line that you're seeing right here is just like saying factorial, which is 1, is equal to factorial 1 multiplied by counter. So 4. Counter is equal to counter minus 1. So counter 4 minus 1. Factorial is factorial 1 multiplied by 1 multiplied by 4. So we have 4 here, and here we're getting 4 minus 1, 3. The same thing. This is just like a little explanation. And then in the while operator, we have a condition here. While counter is less than 0, do this. So while counter is less than 0, we go back and we do this. Okay? If the counter is equal to 0 or less than 0, then we don't repeat this do body, we just go out of the loop. Fine. Let's step this and see how it's going to work. F11. Counter right now is 4. Counter 4. So we'll have write factorial of number 4. Okay? So here we have it. Factorial of number 4 is equal to, but we still don't have the answer. So we move into the body. Do this. Factorial, which is 1, 1, multiplied by counter. Counter is 4. Still remember. And then decrement. So when we go out here, our counter should be 3. Why? 4 minus 1. This is decrement. Remember? So 4 minus 1. Have 3. Then we'll move into our check-in block. Here, while counter, our counter is 3, is less than 0. Is it true? Yes, it's true. So what do? We go back into the do body. We go back into the do body. So here we have counter is greater than 0. It's true. So we go back. And here again, counter is 3, 3 minus 1. Counter has changed to 2. Check it. 2 is greater than 0. It's still true. Okay? Since it's still true, what do? We go back to our do body. Now, counter is 2 minus 1. It should be 1 now. But notice that this changes, okay? This changes. It changes from 1 to 2 to 4 to 12, and now we have 12. The factorial of number 4 is equal to 24. And here you have it. The factorial of number 4 is equal to 24. Now you've seen how factorials work, and it's very easy. Just keep on multiplying and performing this decrement operation until you get 0 and you go out. Fine. Let's move on to the next example and see what we have. So now let's look at a very popular operation used by programmers all over the world today. This is like the loop for or loop with a counter, okay? So here we go. In line 14, let's just explain what is happening here. here we have our operator for, here we have our in-typed variable named counter and assigned a value of 0. So for operator, creation of a variable, and then we have our conditional block here, and then we have our change of the value of our variable here. In this case, we have an increment change here, like post increment change, because the pluses are after the counter or after our variable. So this block, we create some kind of variable. This block, we have our condition, and we compare our condition with our variable value. And then in this block, we change the value of our variable. So, but this doesn't work like this. It doesn't go like 1, 2, 3. What happens is it goes in here first, here, and then here, and then change, and then go back. So it goes round and round and round, but it doesn't go like straight. It goes first, we count 0, fine. Is 0 less than 3? Yes, it is. We print it out. Counter is equal to 0. Then we change the value of 0 and we check it again. It's 1 now, for example, because we have plus plus here. So 1 is less than 3. Yes, it's true. We go down, we print counter is equal to 1. And then we go and change the value of counter and go back again. Let's just step this and see in practice how it works. Here we go. So counter right now is 0. 0 is less than 3. It's true. Now notice this. It doesn't go in here. It goes down. So we move into the body since our condition is true. Counter is 0. So counter is equal to 0. We'll see it printed out. Counter is equal to 0. And then the next step is it won't go out. It will go straight in here. We'll change the value. Go straight in and change the value of counter. In our case, it's an increment change. Okay, so we go in here. Now counter is 0. We go out. Counter is already equal to 1. And then again, we check it. Counter is less than 3. 1 is less than 3. It's true. So we go in and write. Now, what are we going to see? Counter is equal to 1. Remember, we take this and we put it right in here. So when we move out, counter is equal to 1. So what will happen now? We'll go and add one more. Counter is still 1. Go out and counter is now equal to 2. 2 is less than 3. That's still true. So we go in and perform this body. And now counter is 2. So when we show it, what's going to happen is counter is equal to 2. And what next? We go and add 1. Still 2. Move out. 3. Now we check. 3 is less than 3. It's false. So what do you think will happen? Well, not going in here. Just go out. And that's it. So we have counter is equal to 0, 1, and 2. And this is the way it works. First, we create this. We have our condition, and we have our change of the value of our variable. And then it goes condition, writes what's there, changes the value, check the condition, write it, changes the value. Well, you can have decrement here. You can have whatever you want here. It's just a change of a value. Okay? All right. Let's move on to our next example and see. In this example, we also have loop with a counter for with a jump statement and break. Remember what break does. It stops everything. So let's see. In line 12, we have the same value here. We've created an int-typed variable named counter and assigned a value of 0 to it. And we also have our condition block here. Counter, which is now equal to 0, is less than 3. We expect it to be true. And then we have a change of the value of our variable here. The same change and increment. So in this case, we just added break. So what do you think break will do? It will stop the operation and go out. And this will never be executed. So we'll just have one circle and go out. Let's try it and see. F11. Here we go. Counter is equal to 0. 0 is less than 3, true. Move in here. Counter is 0. So we put 0 in here. And we have our break. But first, we have one iteration. It's like one circle. Yes, counter is equal to 0. So let's move on. We have break here. It goes out. It doesn't go back and change the value of our counter. So remember, the reason of using a break is just to move out of whatever you have there. So that's it. This is for using the operator for with a jump statement or break. Moving on to example 14, we have the same thing but with continue. So in line 12, the same condition, the same variable and the same value to the variable, and here we have the same increment sign. Let's step this program and see what will happen with continue. Remember, continue is not like break. It doesn't stop it and takes it out. What continue does is it finishes this, but line 18 will also not be executed. So step in it. Let's see. Counter is 0. Counter is 0, which is less than 3. Yes, we're right. It's true. Go into the body. Counter is 0. And we display counter is equal to 0. And we go to continue. From continue, we'll jump back. Counter is 0 plus 1. Counter is now 1. 1 is less than 3. Yes, it's true. What will happen? Move into the body. Counter is 1. We'll have counter is 1 printed. Okay, we have to just move out of there first. Counter is equal to 1. Continue. Since our 1 is still less than 3, what we do is we go back. We add 1. Counter is 2. 2 is less than 3. Yes, it's true. So we write counter is equal to 2. Let's see. Counter is equal to 2. Very good. So continue. We go back. We add 1. When we add 1 to 2, we'll have 3. So 3 is less than 3. No, it's false. What do? We go out. This line will never be executed. You have seen it because it's in this block, as you can see. So after continue, we don't perform any operations here. We go out of the block and just print out what's happening. All right. Let's stop running the program. And that's it for 4. Let's move into the next example. Okay, let's take a look at this example and see what we have to do. Here we're going to take a look at something that is called nested loop. For nested loop. So, but before that, look at our task here. We're supposed to build a square using asterisk, this sign, okay? Now, let's look at line 12. In line 12, you have something very familiar to you. This is our for operator. Here is where we created our variable. This is the condition, and this is our change of the value of our variable. That's correct. And then inside this for loop, we have another loop. Now this is called a nested loop. It's put inside another loop. So we run this once, we go into this, and we run this, and then we go back to this. Okay, fine. So here you have the same thing, the same condition, and the same construction. But this is inside this one. And I also want you to pay attention to write. It means write asterisk for each time we run this once. For each circle, for each iteration, you write 1 asterisk. That's what we're asking the console to do. Next, I also want you to pay attention to write line. Write line simply means start a new line, which means go under the previous line and start a new line. All right. Now that we have that clear, what I want us to do is to step this program and see how it works together. what we are supposed to expect is it will go in here, and if this is true, we move into the body and we run the body 3 times. Okay, let's change it to 10 times first. Here too, 10 times, so that we have a big square and we can all see it clearly. So here we have this. Let's step the program. What you have here is we first go into our variable, then our condition I is less than 10. Yes, because 0 is less than 10. So what do? We move into the body. Now we're in the body. J is equal to 0. J is less than 10. That's true. So what do? We move into write 1 asterisk. After writing 1 asterisk, we go and change the value of our variable. All right? So now I want you to look at this. We have 1 star. Okay? So we run this again, we check it. J is still less than 10. Why? Because J is equal to 1 now. It's no more 0, it's 1. So we go into the body again and we write 1 more asterisk. 2, and we repeat that 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. So now we have 10 asterisks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's correct. So next, what happens? What happens is we go in here, we start a new line, and then we go back to here, because right now I is 0 and I has to be 10. Okay, so technically we have to create 10 lines. 10 lines, because we'll go through this system 10 times again. So let's see what will happen. Here we've increased 1, it's not working because we have 10 already. We can't have more than 10. 10 is our maximum here. So we start a new line. Now, as you can see, you can see the symbol here just blinking. But if I step it one more time, you'll see it will go to the lower line. Here it is. So what will happen now is we'll go back to our first loop and keep on running it. You can see. Now we've changed the value of I to 1. So we go in here again 10 times. And we're here. So now basically we've gone down to the 3rd line, and you continue like that until we have 10. Let me just press it and hold it. It will move very fast. And when we finish, you'll just see that we'll have 10 asterisks on each line, and we'll have 10 lines. Okay, it's done. Oops. I just closed that. Okay, let's just press F5 or just run the program and you'll see. So this is something that we would have seen if I didn't close that by mistake. So now we have 10 here and 10 here. 10, 10. Okay, let's change this 10 to, let's say, 5. 5 and 5. Let's run the program and see. Now you can see we have 5 stars here and 5 here. All right. So let's imagine I don't want to, let's change this back to 10. Let's imagine I don't want to have a square. I want to have something else. Okay, run. So I don't want to have this whole thing. I just want to have like half of a triangle. Just half of a triangle. What do? I just need to change one symbol here. Let me change this. J to I. Okay, now let's run the program and see. And here you go. So Basically, now we have our half of a triangle. Okay, let's take that back to 10 and save. So this is how you can create a square using some symbols, or create a triangle. And of course, you're free to play with this. I even encourage it, play with it, create as many shapes as you can and see how it works. Okay, let's move on to the next example and see what we have. Okay, the next example we're going to take a look at is Dextrous loop. Well, all this will be explained later, you'll understand it, but before I explain all this, or before we read it, let's go straight to the code and let me show you how it works first. It's very easy, but I don't want this to confuse you now, so we read this first of all, I explain the code, and then you'll understand what we have up here. So let's go down here. In line 33, we created a char typed variable named character and assigned a value to it. And in line 35, you can see our famous for operator. Okay, now the body of this for operator consists of the character that we created, and now we're assigning console read key and key char to this character. This is a very easy code here. It just means that console read key, we're going to take the key or the word or the input of the user and assign it to character. So whatever the user writes here will be assigned to this character. Fine. So in line 40 now, you remember this switch case construction. So switch character, the same character here, we're putting it right in here. So you remember that switch case has, we can change, we're giving the user options. You can choose either case 1, case 2, maybe case 3, 4, 5. In this case, we have just 2 cases. Okay, so if the user in line 41, let's say the first case is L. Okay, case 1 is L. This is called guard condition. And in this guard condition, we have a body. And this body is called the guarded instruction. So if the user presses L, what he should see is go left. And you can see continue, it means we go back and start again. Okay, we go back and start again. Now, what will happen if the user presses R? It will not print go left, it will print go right, and then continue, we go back again. Now, if we don't have something that will stop this program, we'll just keep on going and going and going and going without end. You remember continue, it just keeps on going. It's like goto. So we go back, go back, go back, go back. So continue, go back to character, take what the writer or the user inputs and perform either case 1 or case 2 and go back and go back. So for that, we have break here. We are breaking the loop here. If the person presses, let's say G, it will not perform anything and the application will just close. Okay, so now I want you to look at this guard conditions, like let's say a dog. Okay, and guarded instruction is like something that that dog is guarding. So here we have, let's say gold, and a guard dog is sitting down and guarding this gold here. All right, so let's go back and read these text that we have here. Let me just zoom out a little so that you can see and explain the text. Sometimes I might just have to do this. When Dextrous loop, the calculation of guard condition is taking place in each iteration. So in each iteration or in each circle, we calculate something. If at least one of them is true, the appropriate guarded instruction is taking place or is performed. Okay, let's just write is performed. It's better here. Is performed. All right, followed by a new iteration. So if the user presses L, this instruction is performed, and then we go and start again, followed by a new iteration. Okay? If several guarded conditions are true, only one guarded instruction is executed. If, let's say, this one, this one, this one, this one, if all of them are true, or two are true, or three of them are true, then one of them will be executed. All the others will not be executed. Fine. If all guard conditions are false, the loop is over, meaning that if the user doesn't input L and he doesn't input R, then we go out and close the loop. So it's just break, we go out. Okay, fine. Dextrous loop with one condition and one guarded instruction is in fact a common loop with a precondition loop while. So here what this means is this condition here that we have here, it can be some kind of, let's say, just a while, pre-loop while, meaning we can remove this for and put, let's say, while here and while, and inside this condition we can put true, for example. So it's basically the same thing with this if we had only one condition, but we don't have one condition, so let's take it back and save it. Fine. So if the user presses something else other than L and R, we go out of the loop. That one is set. The classical description of Dextrous loop is DO, OD, P1. Okay, this DO, it's like the marker of loop beginning. In this case, we have our 4 here. 4 is for our DO. OD, marker of loop end. So our marker in this case is break. This means we are closing the loop. PI, the guard condition Boolean expression that we have. Okay, this PI just simply means this guard condition. Okay, PI, we have two guard conditions in this case, guard condition 1 and guard condition 2. Then SI is the guarded instruction. So this is our SI and SI. Now that we know all that, let's read the next one. Loop consists of one or more branches or guard expressions. Okay, now this loop has two guarded expressions or guard conditions, but you can have, of course, 3, 4, 5. Okay, each of which is a pair of guard condition and guarded instructions. Of course, this is a condition and it has an instruction, and this also is a condition and it has its own instruction. Okay, fine. So now that we understand how this somehow works, let's just run the program and see what happens. Let's say we press L, go left, R, go right, L, go left, R, go right, go right, go right, go right, go right, go left, go left, go left, go left, and now I'll press V. Okay, V, go out. You see? So once this condition is met and this condition is met, we'll keep on repeating either of them. If L is correct or if L is true, we keep on repeating L, 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 L until it becomes false, and then we go out. This is a very simple loop. It's just a modification of the basic loops that we have learned. Now next we'll go to spider loop. Okay, the next example we're going to look at spider loop. It's also a kind of modified loop. Okay, first of all, I want you to understand that this spider loop is very similar to Dextrous loop. In short, it's Dextrous loop with a modification. The modification is we have a way of exiting our application. In short, we have two ways. Okay, we have X, we have Q. So here you have 4 options, 4 cases. case 1, case 2, case 3, and case 4. Case 1 and case 2, they perform a type of go left, go right scenario that we had in our Dextrous loop. And case 3 and case 4, they are conditions for ending our program. That is conditions for going out. Okay? Now, let's look at what we have done here. In the 47th line, we created a char-typed variable and assigned a value of 0 to it. And we named our variable character. In line 49, we created a bool-typed variable named flag and assigned a value of default boot. Default bool is false. So that's just like how it is. If you have a default bool value is false. And here our flag, we're creating bool because we want it to be true or false, like a conditional statement. Okay, this is a very familiar operator, I guess, to you now because it's for, and we have been talking about this for a very long time. Next, what we're going to do is we're going to go into line 57 and remember switch cases. We also learned about switch cases. This case, we have the first switch operator. It's taken the value of this character here and putting it into itself. But what's the value of this character? The value of this character is whatever the user inputs. We have read key, so it's in character, of course. So the user presses something, L, R, X, Q, or something else, and it is read and assigned to this character. So this character now will move into this switch or this switch. And here we assign the value of false to our flag. So now our flag is false. We move on to line 59. In line 59, we have two cases. Sorry, in line 51, we have the first case. The first case is when the user presses L. This is like the guard condition 1. Okay? Remember in Dextrous, we had also guard conditions and guard instructions. Here we also have guard conditions and guard instructions. Here we have the first guard condition and its instruction. Second guard condition and its instruction. So if the user presses L, this instruction will be performed. If the user presses R, this instruction will be performed. Fine. Then I want you to pay attention to this break that is here. This break doesn't mean that we're going out of the loop and we're going to the end. No. What this break means right here is we're leaving this switch case and we're moving out of this switch and moving to the next switch. So whenever you press L, go left is written on your screen, and then you have these options. You can press X, and the condition X has an instruction too. The instruction is exit. Then after exit, you have go to end. Remember go to. It's what we use to jump from one part of our code to the other. So the first exit condition, we go to end. Where is end? End is right here, and you go out. Then we also have another one. We have Q, which is the second condition. And Q simply means quit. And after quit, quit is written on the screen, and go to end. We still go back to our end and break. That's all. We go out of the loop. Fine. So this is just like Dextrous loop, but with a modification. If we go out here, we'll see that loop spider modified Dextrous loop with explicit exit conditions. Dextrous loop does not include explicit conditions to continue or exit. So in Dextrous loop, we don't have this exit conditions, okay? But here we have them. So a complicated construction of Dextrous loop called loop spider was proposed. Well, it's not very complicated. Of course, you have seen how it works. In Dextrous notation, it looks like this. So you remember this? Well, we also have this here. We have the beginner of the marker, the end of the marker, and our guard conditions, and let me just take this out, guard conditions, and also we have our guarded instructions. The same thing here. We have the beginning here, and we have our end, okay, and then we have our guard instructions, this one, this one, this one, and this one, and then of course we have our guard conditions, these cases, these 4 cases. So they are very similar and very easy. Now I'm not going to read all this because I guess you understand what I'm doing. You can read it yourself, or if you feel the need, you can check in other places, like you can check Wikipedia and other places, and you'll see the same thing, or at least very similar things, and you will understand it. Let's move on to the next example and look at simplified loop spider. Now, the simplified loop spider is the same thing but a little bit simplified. So here again we have 4 variants: variant 1, variant 2, variant 3, and variant 4. 4 cases, 4 conditions, and here we also added a default condition, which is if the user doesn't press Q, X, L, or R, what will happen is we'll just break it. Alternative, exit and break and come out. That means we're going out of the loop. So this is basically how this simplified spider loop looks like. And that's all. There's nothing to it. Here remember that 4 is what we use. The loop 4 is like, never ending, and that's what we have. Once you have continue, it will keep on moving until you exit it, in which case we have 2 exit options here, and we have a default exit option too. Fine. Let's look at the last example, and that's it. Here what we have infinite loops. These are the 3 different ways we can create infinite loops. We have the while, you remember we have looked at while, we have the do while, and we have for, with these 2 semicolons, meaning it's like an infinite operation. So these are the 3 different methods you can use to create an infinite operation. But of course you can always break it, you can always end it if you wish. We have seen how that is done too. So let's go back to our presentation and we'll see if you have any problems. Just a quick review to see if you understand our presentation better. You know what a loop is and you understand what a repeated instruction is right now. So while this condition is true, perform this instruction and keep on performing until you reach the end of the loop. Now, next on this slide we have goto. Goto means jump into some place in the code. You have seen that and you have seen how it works. Next we have the while instruction or while loop. The while loop is while this condition is true, do this. If it's not true, you go out. Simple. Then we have the do while. The do while is we first check this, we perform this instruction first of all, and after performing this instruction we check if it's true or false. So in the do while, at least 1 instruction is performed. At least you must have 1 iteration. So next we have the for loop, and you know how it works. We have our for here and we create our variable, we have our condition, and we do this, and then we add 1 until our condition is matched, we go out. Okay, so thank you very much for your time and attention. I hope you understand everything we have done today and you've learned something really interesting and useful to you. Till we meet again, I am Rashid Hamid, working for Cyber Bionic Systematics.